Alright, so welcome back. We currently we cleaned a lot of our parts. Specifically right now we're looking at the front iron housing. With all the parts clean, the next step is really to check to see if they're all wind tolerance. So another way to do that is you got to check the factory service manual. The factory service manual will give you your indicators of tolerance. We'll do a couple different measurements. Specifically, this is not exactly flat, but the factory service manual recommends is that you measure across 4 surfaces this way. So here, 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 and here. And what you're doing is you're trying to measure the warpage of the hot iron. We have a feeler gauge, and our goal is to try to fit this 15,000th of an inch feeler gauge underneath. And if we cannot, then that means that the iron is not sufficiently warped. That's good. The second measurement to do on all of these irons is to use a dial indicator, such as this fantastic tool here, and sweep across an area as it outlines in the factory service manual here. Again, we're going to be measuring the difference in the level across the surface of the iron. So we can do that now, and let's cut to that. Okay, it's currently reading about 0. We're going to sweep it across. Try to do this. So generally we shouldn't see much movement here up until the point where it's going to hit the oil seal grooves. And we see some movement there. So it's not even moving about half, so 5 thousandths. It's not even moving that much. So it's generally within spec. Except right there it does move back. There's a visible groove there. Yeah, right there. So we'll work on that. But that's what we do, is sweep across the rotor housing, specifically in this area, because this area is where it's going to get hot the most. So this is a high wear area for these things. 39 or 37 thousandths of an inch. So we can measure this. Basically, it can't move more than 3 tick marks or 4 tick marks away. So we're just going to rotate this across this specific wear section you can see here. And it shouldn't move more than 3 big ticks away. Okay, so we'll try that again. If we look at it, okay, that's where it is. It's kind of at the 3 point, like just a little bit past 3, but not at, it's like 3.25, right in the middle between 3 and 3.5. So we'll just sweep across. And it doesn't move much. So here it jumps up a little bit, but we're still within tolerance, so that's good. This is still okay. Alright, so past couple days definitely I've kept up the cleaning, but now we got one rotor. The surface of it is it's about as good as I would like to get it for now. But the next step is actually clean inside all of the grooves. So there's various grooves inside of a rotor. You can take a look here. But we have the side seal grooves, you have the corner seal and the apex seal grooves, and you have all the oil control rings in the inside as well. So quite honestly, my understanding of a great way to try to clean the inside of these grooves is to use an old one. So this is the used apex seal that was in my engine. And we're just going to keep on grinding away on each side seal here. And there's 3 per face, so there's 6 total on one rotor. And there's 2 of them, so we got to do that 12 times. So clean every face of those. Same procedure again for the apex seals. You would want to take a used apex seal and try to get it really religiously clean inside each unit. So that way when the new stuff comes in, you'll have a nice flush area for that to be placed into. It's all part of the rebuild process. And unfortunately, this is definitely the longest part of the whole process. I heard a great quote yesterday. It said, 50 hours of cleaning and 3 hours of actually putting the motor together. And that's how it works. Alright, so we're back. We actually did a lot of our measurements here on our first rotor. Some of the things that we measured is I measured the clearances here. Basically, I took the tool, measured the differences between right around this point, right around this point, right around this point. Basically measuring at each different point near the apex, but instead of measuring at the point, we're measuring about here at the gear. There's a tolerance of how much difference there's allowed to be there. We're generally going to go there. I also cleaned each of the side seal grooves with another used side seal. And with the side seal in place, you can measure that tolerance as well. So that was also measured on every face. We're good to go. And finally, stuck the old apex seal back in there and measured what our tolerance is for that. So here it is. You just stick it in and like so, and then measure what tolerances you're looking for. This is your best friend. It's a feeler gauge. But yeah, we're actually good to go on this first one, so we'll move on to the second one. Hey y'all, so we're almost there to 100 subscribers, and at 100 we'll be giving away a rotor and a housing that was from my old motor that was a little damaged, but you can use it as bookend, you can use it to make a clock, plenty of different cool things you can do with it. But we're almost there guys, so I'm happy with what we're doing so far. Thank you for coming.